Good morning, good evening, wherever you are. My name is Mark Borstein. I'm the CTO of Tremolo Security and the co-author of Kubernetes and Enterprise Guide Second Edition of my partner in crime, Scott Surovich. So last time we went through how you authenticate to your cluster. How do users get into your cluster, whether you're using OpenID Connect or you're using impersonation for managed clusters. Um, Now, a couple of things have happened since then. Uh, One thing I'm really happy about is that Packet has decided to release this chapter, chapter 5, as a completely free PDF. So I've got a link to it in the description of the video, but it's completely free. There's no registration wall, there's no DRM. It's just a good old-fashioned PDF. You can read it on any device, anywhere. Um, so you can actually go and if you haven't bought the book yet, download that chapter and you will learn more about Kubernetes authentication than you ever thought you needed to know. So that said, let's talk about today's labs. We are going to build off of the lab we went through last time. So if you need help or you haven't yet built out your OpenUnison deployment for the previous lab, now is a good time to do that. If you want to watch a video, and let's see if I'm doing this right, there will be a video link here, I hope, maybe. I haven't done this before, but I think this is how I do it, to last week's video, and it'll also be in the description. So that said, let's talk about how pipelines authenticate to your cluster. When you work with Kubernetes, a big benefit is not just to say, hey, I have Kubernetes on my resume, but it's to be able to automate things. And the most common mechanism to do that is a pipeline. And we're going to get really deep into pipelines in the last chapter, chapter 14. But suffice to say, a pipeline is just a series of steps that usually end with updating a manifest in Kubernetes to say, hey, go point to this container or go update from this Git repo or whatever's going on. And so how does your container actually, or how does your pipeline actually authenticate to the container? Well, in chapter 14, we're going to be using Tecton CD, which is part of the Knative project. And Knative was originally designed to give you a serverless foundation, function as a service. And part of that was a build system called Tecton CD, which is you can run on your own. And we do that in the final chapter when we do pipelines. So when Tecton runs, it's running inside your cluster, so you can just use a service account to do authentication. You don't actually have to do a lot. But a lot of people run systems from outside of their cluster. GitLab, GitHub, Jenkins, just about anything you can think of. They're often running outside of your cluster. They're going to manipulate your cluster. And how do you authenticate securely? So the first part here, we're going to talk about tokens. And so the interesting thing about the interesting thing about Kubernetes is that once you've integrated an OpenID Connect provider and tokens, it doesn't care how you generated that token as long as the token's valid. So if you generated a token by logging into OpenUnison and running a kube control command, great. But if you generated a token by, say, calling an API, as long as that token is valid, Kubernetes will accept it. And so our OpenUnison that we have deployed is deployed against an Active Directory. And the nice thing about that is it means that there is a username and a password we can use. So what we actually did was we made an update to OpenUnison here in the book that actually let us use a basic authentication mechanism. So instead of authenticating with a login form, we're going to do it using HTTP basic authentication. So that makes it a lot easier to reuse existing credentials. Where might this come in common or come in handy? If you are a large enterprise and you already have a large investment in something like privileged access management, where you need to check out the account and go ahead and run your pipeline to do your deployment and then check the account back in, this will do a great job for that. So I'm going to go ahead and let's log into my oops, into my server. And I am on page 202. So we're going to use Helm. And the great thing about Helm is you can install whatever you would like. So I'm going to go ahead and install Token API. So this is a set of configurations for OpenUnison that says, okay, instead of pulling the token from a username password form, we're just going to go ahead and pull it directly via an API. And open, of course, if I knew how to type, it'd be a lot easier. Chapter 5, OpenUnison values YAML. All right. Installation failed. Home. Oh, right. Did the name, I missed this part. Chapter 5, token login. And we'll take a quick look at the config once it's deployed. So what's going on here is Helm is generating manifests based on our templates. It's deployed it. And now that that's done, we can go ahead and start tokening. So what we're going to do here is let's go ahead and step through this and see what happens. The first thing we're going to do is we are going to get a token. So what do I mean by that? So we're going to do curl insecure. My account is going to be pipeline service account. Now this is an account that is in the test directory we deployed for OpenUnison. And we're going to do HTTPS k2u.192.168.2.104.nip.io Kate's API token user. And what I'm going to do here is I'm actually going to add a -v so we can look at the headers. And did this work? It did. Okay, so a lot here to unwrap. So let's look at the request. I like diving into the nitty-gritty details. So we're making this request, and here is the important bit, this authorization header. So this is the header that our curl command is authenticating to OpenUnison with. So it's calling OpenUnison and saying, hey, here are my credentials. And it's the base64 encoded version of this username and password. So now what happens from the response? Well, we get this big mess of JSON from OpenUnison. Now what's interesting about this is, let's come back here, and I'm going to go ahead and log into my OpenUnison instance. And of course, I'm not going to use the right password. There we go. So I'm going to come over here to tokens, and the fun thing about this screen here, where we got our kube control or our Windows kube control configuration from, is that this is just a HTML5 app that calls an API. So I'm going to go and do F12, and let's go ahead and refresh this. So this is a lot of nonsense, and then here's really where the rubber hits the road. This is the exact same request, except it's going to a different URL that is protected by form authentication inside of OpenUnison. And here's the response, is this big giant mess. So the only difference between this and this is that this was authenticated using HTTP basic auth, whereas this was generated by logging in via a form. So that's the beauty of APIs and identity, is you can mix and match the way you need it to. All right, so there's a lot here that we don't need. We just need a ID token. So let's go ahead and let's get rid of the -v. And let's pipe this into JQ. So JQ is kind of the Swiss Army knife of JSON management or JSON command line management. And you can see now that the JQ-R broke up our response into something that's a little more manageable. So what we really need is this here, is this ID token. Okay, because that's what we're going to use to talk to Kubernetes. So the next thing we're going to do is we're going to say, all right, let's run this again, but this time we are going to get just the token ID token value. Oops. Of course, if I knew how to spell, that would help. And then I'm also going to pipe to into dev null, because we don't really need to see all of the stuff from curl about how long it takes to download. So, okay, so we got this ID token. Now what are we going to do with it? Well, we're going to stick it in an environment variable just to make our lives a little easier. So export kube az equals that. So now just to show you there's nothing up my sleeve here, that's now our ID token. So now we can use this token in curl. So let's go ahead and curl insecure. I'm going to do a -v so we can see the headers. And we're going to create our own authorization header. Oops. Kube and we're going to go to 0.0.0.6443 API. All right. So that did not work. Probably because I let my token expire, because the token's only good for a minute. So let's see if we run this time it works. Nope. Authorization. Oh, I didn't do this part right. There we go. Okay, so this time, here's our authorization header. So what we're doing is we're taking the ID token that we generated from OpenUnison, so that's the same identity provider that we use to log in to Kubernetes with, except this time we're just generating a token so that we can securely interact with our cluster. And we're just taking that and putting it into a request to the API, and it's coming back that we're getting something out of there. Maybe we want to do something a little more interesting. What is it? Namespaces? Is that going to work? No. I don't remember off the top of my head. That's what reference documentation's for. But the key here is that this is the way kube control works, right? If you did a kube control and then went ahead and did kube control -v, all it's doing is making the API calls with the ID token. So we're just doing that, except now for our pipeline. So we're using the same mechanism here, username and password, to be able to get a credential that is valid for Kubernetes, that Kubernetes doesn't actually know the credential, which is good, so it doesn't leave our pipeline. And yeah, you're now in good shape, and you can actually start working with the API server however you'd like. Now, one thing that to point out is that, let's say for the sake of argument that you didn't want to do this, let's say this is a managed cluster and you want to be able to access this stuff that way as well. We can do that. So let's go ahead and let's get our command for generating a token. I think this is it. Yep. So let's go to my local workstation, and we're going to have to, what we'll do is, I actually don't want to do that because I don't want to have to resize everything. So I'm going to go ahead and log out, and let's do export kube config gets temp u. Kube control get nodes. Doesn't work, right? All right, so let's do curl v, or let's do curl insecure HTTPS. What is it? Kate. Let's come back here. Do I have it in here? I bet I do somewhere. What is it? Kate's API. Here we go. So this is going to be our reverse proxy. Kate's API, unauthorized, right? So now let's go ahead and run our command. So we should now have a a token, an ID token. So now let's go ahead and, oops. So now instead of going directly against the API server, we're going to use that same token against our reverse proxy that we did for impersonation. So let's pretend our cluster is running on Amazon, for example. So we're going to do H authorization bearer right? And there you go. We're actually able to access it through our reverse proxy. So that's a great part of doing it this way, where you first authenticate your pipeline to the identity provider, get a token, and then access your API with that token, is that it will work regardless of if you're running on a local cluster, inside of your data center on your laptop, or if you're running on Amazon, Google, Civo, whatever. It'll work the exact same way, so you can have some consistency. And so if we give this a moment or two, because this ID token is only good for a minute, yep, there you go. So it's already not authorized. So we would have to generate a new token. And there you go. So that's another benefit of doing it this way. You have short-lived tokens, so that way anybody gets access to that token, just like when you're accessing Kubernetes as a developer or an admin. It's only good for a minute, so by the time somebody gets it, knows what they have, it's kind of useless. So let's say you don't want to use tokens. Let's say you really just, you prefer to use certificates. That is a decent option. The nice thing about certificates is that, log in here again, you don't need an external identity provider for it, right? You can just go ahead, generate the certificate, generate the key. If you do it properly, store it in your pipeline, and then you can just interact with your API server. The major downside to this approach is it generally won't work with managed clusters. And that's because the API that we're going to use to mint and trust the certificate is not available on most clusters, managed clusters like EKS, AKS, etc. The key that's used to sign the tokens is not available to the cluster operator. It's only available to the vendor. And so this would work great for on-prem. It generally will not work for managed clusters. But that said, let's go through and see how it works. Now, one thing I will point out is that I am very much a opponent, I guess is the right word, of using certificate-based authentication. And the reason for that, we'll go through as we go. But in order to do this properly, pretend that we're launching, we're creating a GitHub action, or we're creating a um, like a GitLab pipeline or some kind of external pipeline, um, these steps need to be separated so that the key never goes over the wire, which we'll see is a bit of a pain. So let's go ahead and first we're going to do this, and I'm actually going to say, okay, I didn't think that that worked the way I wanted it to. Good old copy and paste. Let's go ahead and do this a bit at a time. And let's walk through what this command is doing. All right, so what this command is doing is we're using OpenSSL to create a new certificate signing request and a new key at the same time, 2048 bits. We're not using DES, which means our key won't be encrypted. We're going to generate a key to SACert key. Our subject is going to be the user, which is the common name, is SACert. The O, so whenever you have an O here, that is a group. So in a token, we had groups in a group claim. Here, we're putting our groups inside of the subject. Every O component you have is a group. And we're going to have the group, OU is SA cluster admins. So we generated this new key. Okay, nice private key. And then we also have a CSR, so a certificate signing request. So if you're unfamiliar with the way certificate authentication works, you have a public key and a private key. So that was our private key. And then in order to be trusted, you take your public key and you put some metadata on it and you submit that package to a certificate authority. So that's what's called a certificate signing request. So like if we take a look at CSR in OpenSSL request text, no out, verify in CSA. There we go. Okay, cool. So here's our request. This is the subject that we created it with. Here's our public key information and our signature algorithm. So the next step is to take this and submit it to a certificate authority and get signed. That's how we actually get a certificate. And because we want our certificate to be trusted by Kubernetes, we need to submit it to Kubernetes built-in certificate authority. Now, this is different than Cert Manager. Cert Manager has its own API, its own objects, completely separate from what the API server provides. This is a completely separate API. This API is designed for things like nodes that need certificates, service accounts that need certificates, etc. So let's go ahead and submit it. All right, so let's go ahead and copy this. And because this didn't get formatted properly, all right, so what are we doing here? We're creating a certificate signing request. It's called CA-cert. It's coming out of the same CSR that we just created. And its usages are going to be for digital signature, key encipherment, client auth. So what's going to happen is that Kubernetes is going to create a certificate signing object inside the CA, which somebody's going to have to approve. So let's go ahead and let's run this. And it's taken a minute. Okay, cool. So if we do kube control get certificate signing requests, there we go. So there's now a certificate signing request that is pending. So now a administrator like ourselves needs to log in and approve this request. We can do that using kube control. So certificate approve SA cert. So we're going to go ahead and run that. And now when we get our certificate signing request, we'll see that it's been approved and issued, which means we now have a certificate that we can use to go with our private key. So the next step is we're going to go ahead and get that certificate. So let's go ahead and show what this looks like. So we're going to get the CSR object, so the certificate signing request, SA cert. So that's what we created up here. And then we're going to look in the status. That's actually where the certificate is stored because that's the only thing that can be written to, once it gets created. So that's now our base64 encoded certificate. So let's go ahead and pipe that into base64-D. So that now creates PEM. We're going to pipe that into cert.crt. So we now have a certificate. And if we take a look at this, X509 in SA ERT, I have to fix that. No out and text. And of course, because it's not OpenSQL. All right, so here is the certificate that was issued. It was issued by CN equals Kubernetes, so it was issued by the Kubernetes CA. And here's our subject. We have a user named CA cert in the groups SA cluster admins and OKates. Now, one thing that's really important here, and we'll get to this with RBAC, you can put yourself in whatever group you want. So if you want to put yourself in O equals system : masters, which bypasses RBAC, not cluster admin, it bypasses RBAC altogether, you can do that. And if the Kubernetes admin approves it, so you got to be really careful about who you allow to approve certs, when certs get approved, and make sure that you're actually looking at the certificate signing requests. So a lot can go wrong here, which is another reason why I recommend not using certificates. So that said, let's go ahead and rename this file SA ERT to SA cert, or yeah, SA cert.crt. Okay, so we now have a key pair that we can use with Kubernetes. Now the trick is we have to actually use it. So we're going to go ahead and go ahead and just make a real quick backup here of our existing config. We don't want to lose it. And then we're going to make sure that we use our existing config while we do this work. Yep, okay. So I'm actually going to, yes, we're going to do that. Now, so then the next thing we're going to do is kube control has this great thing where just like OpenID Connect, you can use its command line parameters to set almost anything. So what we're actually going to do here is we're going to set up our kube control configuration to use our key and certificate. So what we're saying here is we're going to do kube control config set credentials kind cluster 01, so that's our cluster that we're using right now. Instead of the existing key that we're using, we're going to go ahead and use our new SA cert key and our new SA cert certificate. So instead of authenticating with the master certificate, which should really be break glass in case of emergency, we're going to authenticate with the key pair that we just generated. So we've gone ahead and set our cluster. So now let's go ahead and get nodes. And it's forbidden because we're using the SA cert user and the SA cert user doesn't have permission. So let's go ahead and reset that. So we're going to go back to our normal config, right? So we're back to normal. And let's go ahead and we're going to cover RBAC in the next chapter, but just to show you there's nothing up my sleeves. So we create a role binding called SA cluster admins. Chapter 5, SA cluster admins. So what's happening here is we are using the group SA cluster admins, which is here, this O equals SA cluster admins. So that's one of the groups that our user is a member of. And we're granting it the cluster admin role, cluster admin cluster role. So now, if we try this again, control get nodes, it's more with feeling. Oh, there we go. So now I can actually access get nodes because my certificate has cluster admin rights based on that cluster role binding. So as the last lab, before we wrap it up, why do I tell you that this is a really bad idea? Why do I say this is called an anti-pattern? Well, first off, let's take a look at our certificate. Our certificate is good from today, March 8th, GMT, 2022, till March 8th, 2023. This certificate is good for a year, which means if somebody gets a hold of this key pair, there is absolutely nothing you can do to stop it other than rekey the entire cluster. Whereas if somebody got a hold of the ID token that we use, it's only good for a minute, so who cares? I mean, not who cares, but the point is by the time an attacker gets it, figures out what it's good for and tries to use it, it's expired. Now they might get a little bit of information out of it, but at the end of the day, it's a short-lived token. It dies quickly. Whereas our certificate here, it's good for an entire year. Now there are solutions out there for what's called revoking certificates, but the problem with that approach is that Kubernetes doesn't do it. Kubernetes has no support for certificate revocation. There are multiple methods out there, and Kubernetes does not support any of them. And so ultimately, you now have this long-lived token, and it's a token, that is impossible to revoke without rekeying your entire cluster. And that is a non-trivial task for anything other than a kind cluster or like a single node kubeadm cluster. If you want to change permissions, you can't, because you've got this key that's good for a year. And look at all the different steps you had to go through to make that work. If you really wanted to use certificates, what I would actually suggest is configure your identity provider. Like you can do this with OpenUnison, you do a key cloak. Don't think you can do it with DEX, but configure your identity provider to support certificate-based authentication. Then use your cert against the identity provider to get a short-lived token, and you're good, right? You get the best of both worlds. You get a permanent key that sits on that sits in your pipeline that doesn't go over the wire. It's not a password, but you don't have to worry about certificates that can't be revoked. You can use a different CA to generate those certs. So that takes us to the end of Chapter 5, Authentication. Next chapter is RBAC, and we're going to talk about all sorts of great stuff. We're going to talk about how you enable RBAC. We're going to enable RBAC manually inside of kubeadm, how you debug RBAC, how you enable the audit log. Smash that like and subscribe button. It makes a big difference. If you haven't picked up a copy of the book, we'd love you to. And like I said before, this episode, the chapter for this episode is 100% free, no registration wall, no nothing. It's checked into it's actually checked into our Git repo. That's where they decided to put it. So no tracking or anything either. Nobody knows that you downloaded that PDF, I promise. So anyway, thanks for joining us. Have a great day and look forward to talking to you next week.